In a world where true fifth-generation jet fighters rule the skies, the F-22A Raptor is one of the lions of the sky. This craft was designed to replace the F-15, its fourth-generation predecessor, with emphasis on agility, stealth, and range. The F-22 truly understood this assignment and delivered as sightings of this craft in simulation combats and real enemy attacks, showing that this plane is truly a feat of genius. All these and more about the F-22 are coming up in this video, so stay tuned. The F-22A Raptor is an advanced tactical fighter aircraft developed for the U.S. Air Force. The advent of the F-22 was within the scope of objectives of the Advanced Tactical Fighter ATF program. The program had its origins in numerous U.S. Air Force air combat studies carried out in the late 1970s and early 1980s, when intelligence revealed the Soviets' early flight testing of their Fulcrum and Flanger. It was clear that both types would have the vortex lift performance to challenge existing U.S. aircraft like the F-15 in direct combat. In 1981, the Air Force developed a requirement for a fighter of the ATF program as its new air superiority fighter. It would take advantage of the new technologies in fighter design on the horizon, including composite materials, lightweight alloys, advanced flight control systems, high-power propulsion systems, and stealth technology. They believed that these new technologies would make aircraft like the F-15 and F-16 obsolete by the early 21st century, and they did. The F-22A Raptor is an advanced tactical fighter aircraft developed at Aeronautical Systems Center, Wright-Patterson Air Force Base in Ohio. The Raptor is a supersonic dual-engine fighter jet that won the 2006 Robert J. Collier Trophy from the American National Aeronautic Association, among other notable recognitions. It is the world's first fifth-generation jet fighter and is considered so in the U.S. Air Force inventory using low observable technologies, modern avionics, and efficient engines to offer an air of superiority in a fighter unmatched by any other modern military at the time. The F-22 Raptor, a critical component of the Global Strike Task Force, is designed to project air dominance rapidly and at great distances, defeat threats attempting to deny access to the nation's Air Force, Army, Navy, and Marine Corps. A combination of sensor capability, integrated avionics, situational awareness, and weapons provides a first-kill opportunity against many threats. The Raptor also possesses a sophisticated sensor suite, allowing the pilot to track, identify, shoot, and kill air-to-air threats before being detected. Significant advances in cockpit design and sensor fusion improve the pilot's situational awareness. In the air-to-air configuration, the Raptor carries 6 AIM-120 AMRAAMs and 2 AIM-9 Sidewinders. The F-22 has a significant ability to attack surface targets. In the air-to-ground configuration, the aircraft can carry 2 1,000-pound GBU-32 Joint Direct Attack munitions internally and will use onboard avionics for navigation and weapons delivery support. In the future, the air-to-ground capability will be enhanced with the addition of an upgraded radar and up to 8 small-diameter bombs. It will also carry 2 AIM-120s and 2 AIM-9s in the air-to-ground configurations. Advances in low observable technologies provide significantly improved survivability and lethality against air-to-air and surface-to-air threats. The F-22 Raptor brings stealth into the day, enabling it to not only protect itself but also other assets. The F-22 engines produce more thrust than any of their predecessors. The combination of sleek aerodynamic design and increased thrust allows the F-22 to cruise at supersonic airspeeds greater than 1.5 Mach without using an afterburner, a characteristic known as supercruise. Supercruise greatly expands the F-22's operating envelope in both speed and range over preceding fighters, which must use fuel-consuming afterburners to operate at supersonic speeds. The sophisticated F-22's aero design, advanced flight controls, thrust vectoring, and high thrust-to-weight ratio provide the capability to outmaneuver all current and some projected aircraft of other countries. The F-22 Raptor design has been extensively tested and refined aerodynamically during the development process. The F-22's characteristics provide a synergistic effect, ensuring F-22A lethality against all other relatively advanced air threats. The combination of stealth, integrated avionics, and supercruise drastically shrink surface-to-air missile engagement, enveloping and minimizing enemy capabilities to track and engage the F-22. The combination of reduced observability and supercruise accentuates the advantage of surprise in a tactical environment. The F-22 has better reliability and maintainability than other fighter aircraft before it. Increased reliability and maintainability pay off in less manpower required to fix the aircraft and the ability to operate more effectively. By 1990, Lockheed Martin, teamed with Boeing and General Dynamics, had built and flown the demonstration prototype aircraft, designated YF-22. The first F-22 fighter aircraft was later unveiled in April of 1997, and that was when it was given the name Raptor. In September 2002, the United States Air Force decided to redesign the aircraft F-A-22 to reflect its multi-mission capability in ground attack as well as air-to-air roles. The aircraft's designation was changed again to F-22A when it achieved initial operating capability in December of 2005. The decision to proceed to low-rate initial production was authorized in August of 2001, and Lockheed Martin delivered 49 aircraft under LRIP contracts. Initial operational test and evaluation began in 2004 and was completed in February of 2005. The F-22A Raptor went ahead to achieve full operational capability in December of 2007. More recently, in May of 2019, the United States Air Force's F-22 fleet received an upgrade to modernize the application development process. The aircraft has a length of 1.89 meters, a length of 5.1 meters, and a wingspan of 13.6 meters. It has a range of more than 1,600 nautical miles. Its construction consists of 39% titanium, 24% composite, 16% aluminum, and 1% thermoplastic by weight. The titanium is used for its high strength-to-weight ratio in critical stress areas, including some of the bulkheads, and also for its heat-resistant qualities in the hot sections of the aircraft. Carbon fiber composites have been used for the fuselage frame, the doors, intermediate spars on the wings, and for the honeycomb sandwich construction skin panels. The throttle of the fighter is filled with hands-on throttle and stick control. The cockpit has 6 color liquid crystal displays. The Kaiser Electronics Projection primary multifunction display provides a planned view of the air and ground tactical situation, including threat identity, threat priority, and tracking information. 2 other displays provide communication, navigation, identification, and flight information. 3 secondary displays show air-to-ground threats, store management, and air threat information. A BAE Systems Heads-Up Display (HUD) shows target status, weapon envelopes, and shoot cues. A video camera records data on the HUD for post-mission analysis. The AN/APG-77 radar was developed specifically for the F-22 by the Electronic Sensors and Systems Division of Northrop Grumman and Raytheon Electronic Systems. The radar uses an active electronically scanned antenna array of 2,000 transmitter/receiver modules, which provides agility, low radar cross-section, and wide bandwidth. The aircraft's electronic warfare system includes a radar warning receiver and a BAE Systems Information and Electronic Warfare System (IEWS) missile launcher. The TRW Communications Navigation and Identification System includes an intra-flight data link, Joint Tactical Information Distribution System link, and an identification friend or foe system. The Boeing Company is responsible for mission software and avionics integration. The aircraft has a Northrop Grumman LTN-100G laser gyroscope inertial reference, a global positioning system, and a microwave landing system. Engine-wise, the F-22 is powered by 2 Pratt & Whitney F119-100 engines. This engine is a low bypass turbofan engine that can provide up to 156 kN of thrust. Thrust vectoring is controlled by a Hamilton Standard Dual Redundant Full Authority Digital Engine Control. This FADEC is integrated with the flight control computers in the BAE Systems Flight Controls Vehicle Management System. The F-22 made its combat debut in Syria against the IS in 2014. It was used in the strike role, dropping guided munitions from its internal weapons bay. The mission was the equivalent of going after gophers in the kitchen garden with an anti-tank rifle. In other words, while the F-22 would certainly get the job done against the IS and their firepower, sending the F-22 was clearly overkill. The The mission has been seen by many as a desperate attempt by the Air Force to make the F-22 look relevant and useful in the face of stratospheric development, procurement, and maintenance costs. And the mission could have been executed just as well by just about any other fighter bomber in the United States Air Force overseas inventory. The F-22 is yet to face a scenario that it was designed for from the conception level, going up against sophisticated enemy fighters in a high air defense threat environment. Production of the F-22 fighter jet was officially terminated when Defense Secretary Robert Gates announced that the Pentagon would end the Lockheed-run F-22 program and increase the production of the F-35 Joint Strike Fighter. The last produced F-22 was delivered in 2012, and 183 F-22s are currently in service with the United States Air Force. We'd love it if you'd leave a comment down below and let us know your thoughts on this 5th generation fighter jet, as well as which of its features stood out as the most impressive to you.